Hi and welcome to the Polybox. Today we are going to create a nice abstract wire art, which in the end, after you textured and lighted it, might look something like this. Now, for this to actually work, you're gonna need release 21 because we're gonna use the field forces object, which is not available in release 20, unfortunately, and below. So there might be ways to do it in other releases, but we are going to use the field forces object. So you are going to need release 21 for this, which is an exciting new feature, especially for stuff like this. So let's not talk around the topic too much and get started. For this experiment, we're going to use the platonic object and change it to dodecahedra because it just looks interesting. Now, the field forces object works with vectors, and this is not a vector, this is a polygonal object. So we need to create vectors coming from this object. For that, we are going to use the volume builder object, drag it below so we get voxels. And this has a new volume type field where you can change the generation type basically from signed distance field to vector. And now we have created vectors from our object. Now at any point you can visualize what your particles do in the object, which is recommended because it's kind of hard to see what these vectors actually do, especially the direction and the color, etc. It gets really convoluted. So for this reason, I always just add a quick emitter just to emit particles inside my object. But we need more particles. So let's just increase that. And as you can see, right now it does nothing. The reason for that is that we just generated vectors. We're not applying forces to the particles here. So to do that, we need to add the simulate forces field force object. Now we need to tell the field force object where the vectors are actually coming from. So go to your field force object and drag your volume builder object inside of it and choose volume object. Now we told the field forces object that we want to use the vectors generated by the volume builder as force. So we're going to increase the strength now, otherwise we're not going to see much. Let's go to 150. And if we shoot our particles inside now, you can see that we get a reaction from the particles because now we're actually applying forces to the particles. But 150 is too much. So let's reduce that to, let's say, 25. That looks better. All right, this is of course not the effect we're looking for, but this is what I meant with visualizing it. So for now, you can hide the volume builder object because all the vectors that are happening are going to be displayed by the field forces object anyways. So go to display and just increase the vector count to something that looks usable, something like maybe 25%, and disable display vector length so all the vectors look the same. All right. Now we don't have that mess because if we have both objects activated at the same time, we basically get double the vectors, which is just confusing. All right, as I said, we don't have the effect we wanted yet because for now the particles are just bouncing away from the object. So what we do next is we go into the volume builder and create a random field. And let's double check it's not actually inside the volume builder and inside the field force object because that sometimes happens and that screws stuff up. And just drop it below in the volume builder as well. So now we have a random field in the volume builder and it's creating a random field inside this box, which is not what we want because we want the random field to actually generate vectors inside the volume we already have. So go inside your volume builder, go to random field and change the creation space from box to object below. Now the random object only creates vectors inside the shape we already have, which is the platonic object. So if we disable the platonic object, like this, we don't get any vectors at all. Now for now, this is only, well, creating random fields or random vectors inside this object, but we want to kind of cross it, which is exactly what we're going to do because we are going to change the random field mode from normal to cross. And now we get an interesting mixture of the base object, the directions of the base object and the random field. Now if we shoot stuff inside it, you can see it's not strong enough or it's not working because we need to change the field force velocity type from add to velocity, which basically just changes the direction of an object or of a particle, to set absolute velocity, which basically overrides any kind of velocity or direction a particle has in the first place. So I'm not really sure why this happens, but as soon as we change the field force from add to velocity to set absolute velocity, this particle emitter refuses to work, which is now why we are now going to switch to something that we needed to do anyways, but I was planning it for later. So just delete your emitter and get a matrix object. Now what we're going to do is we're going to create particles on the surface of our base object, but instead of the standard particles we just used, we're going to use thinking particles. Now don't flip out, there's not going to be much espresso. We need some, but only 2 nodes and a connection to make this work. Because many people flip out when they hear thinking particles, including me, but it's actually really easy. So take your matrix object and switch the mode from grid array to object and drag your platonic object inside. And now change it from generate matrices only to thinking particles. All right. And now, as you can see, we are creating particles on the surface of our platonic object. It doesn't look like it because the volume builder gives the vector some, let's call it depth. As you can see, it's inside, but if you look at the object, it's straight on top of it. All right, change that back, cross, all right. Now, to make this work, just create a expressor tag on top of your matrix object and type into the search field pass and take the p pass, which is basically the particle pass, and then get force, take the p force object, connect this, go into the p force object and drag the field force inside of here, which basically just tells the thinking particles pass that the field force object should influence the particles, and that's about it. So now if we simulate this, you can see we get some strange movement, but we get movement. Now this is obviously not strong enough. So we're going to a field force object and just increase the strength to something stronger until we get something that works for us. Now it doesn't look good yet, but it's going to get better, don't worry. Now let's go with 500 maybe. Yeah, that looks great. All right, now the noise is way too small. As you can see, we can't really see any swirliness in the noise. So go back to your random field object and just increase the size of the noise until you get something that looks like it might work. Now this is a good coloration of the vectors. And now if you play this, you can see we get this swirly effect, the particles just flowing around inside the noise. This is of course not enough objects, not even close, not enough particles. So just go back to your matrix object and increase the count to something that just a lot of particles. Now the problem is here we only see these shitty boxes, but we can actually just hide the matrix object and still see the particles flowing. Hit play and you can see the particles are flowing around inside of the object. Now, an interesting thing about the field generation is that the voxel size doesn't only influence the signed distance field, but also the generated vectors. If you hide the field force object and show the volume builder object and you decrease the voxel size, you can see that we get shit ton of vectors. Be careful with that because you might actually crash your Cinema 4D with that. So let's just reduce this a bit, maybe 3. This looks healthy, I guess. And just hide the volume builder again, go back to your field force and maybe increase the display line density until you get something that you can work with. If we hit play again, we now get a more detailed animation basically because we just have more vectors that Cinema can work with. Just for the sake of it, because we're looping pretty fast here, increase your frame time of your project to something like 200 for now. And now you can see your vectors flowing inside your object very, very, very nicely. What I noticed when working with this is that the the vectors don't really like hard corners on polygons, so what I recommend is always getting a bevel deformer, putting it below the object and just smoothing your corners out to something that you think just still looks great, and increase the subdivision to like 3, 5, something around that area. And don't forget to put it back into the volume builder and correct the order. If we play the animation now, you might see that the particles just flow better around. They don't get stuck as much. They still get stuck, but this is something you can't really avoid. But it's not a big deal. It still works. Okay, so now how do we get the spaghetti or the wire outside of just the moving particles? This is where MoGraph comes in. We go to MoGraph and get the tracer. And we drag the matrix object. This doesn't have to be here. Into the tracer. And now if we play this, you can see we get these nice splines swirling inside the object. And this is what we are going to use to get our wire effect. This is the point where you can really preview what you're actually getting by hiding everything and then just playing around with settings. So you might think these swirls are too big, so just go back into your random field object and just decrease the size and play the animation again. And you get way smaller swirls now. But I think we still don't have enough particles, so go back to your matrix and just increase the count. I'm gonna double it now. 400 particles is not really much. And play again. And we get a really nice effect now. This is a lot of swirls and I really like this effect. And before we proceed, let's just save our project. Because, yeah. The next thing is where you might crash your Cinema 4D if you have too many polygons going on. So, if you have ever worked with a tracer object, you know that it just generates splines, of course. And what we can do with splines is just use them in a sweep. So, take your sweep, place the tracer inside, and get whatever you want. In this case, we're going to use a simple circle, decrease it in size, because otherwise we get polygon mess, and decrease the number of sides on the spline. Otherwise, you will crash your system pretty fast because it's a lot of polygons being generated. Then drag a circle inside the sweep, and we get the effect we're looking for. I think the spline is way too big still, though. So let's go to 1 maybe. Maybe even lower, 0.8. This is just something you have to configure because it's, you know, your creativity. And as you can see, we still have these ugly corners and ugly edges inside the thing, which we really don't want. This is where you go back to your tracer again, and you can change, just like in every other spline, you can change the spline type inside the tracer as well. And for this kind of project, the cubic spline works pretty well. And the Akima spline works pretty well. The B-spline sometimes works, sometimes it doesn't. This is just something you have to try out, just be creative. And as you can see, we don't really see an effect right now, but if you change the intermediate points to something like adaptive and reduce the angle to something like 10%, you can see we get way smoother splines now, but this is not smooth enough for my taste, so we're going back to the circle and now just increase the subdivisions again until you get something that you think you can't really see the polygons. 2 is enough most of the time, but this really doesn't look smooth enough for me yet. So let's reduce the angle again. And this is looking way better. Sometimes you have to redo the simulation to actually get correct effects in this case. So I recommend disabling the sweep, otherwise you are going to calculate sweeps in real time, which is slowing down your system really fast. So disable the sweep, do your simulation again. Stop at whatever point you like now. Enable the sweep again, hope Cinema doesn't crash. And we still have edges inside it. Now this is a thing with the detail and the amount of vectors you have. The less vectors you have, the more edgy your splines are going to be. So you have two choices. Either increase the volume builder detail to something ridiculous, and you get way smoother vectors. As you can see, if we create the sweep now, these vectors are looking way smoother. But the other way to do this is make the tracer only track a sample every so and so steps. So right now it's making a point for the spline every frame. But if we increase the sample step to something like 5, you can see that it only disable the sweep, don't forget that. You can see that it kind of strings along. It's probably easiest to see if we disable them, if we decrease the matrix object count, something very low. And now you can see it kind of creates a smoother spline because it's only creating a intermediate point every 5 frames. And you can see the spline interpolating differently as soon as a new point is generated. Now you can overdo this, of course. You can do something like 25, which is only 1 point every second. But at this point, you're losing all your detail in your spline. It can be a great effect if that's what you're after. This is the great thing. You can just be creative. So let's increase our count again. Let's see what happens now. Yeah, now you can see it's just kind of a mess, but it can still look great. So this is just something you can experiment with a lot, which is amazing. This is the power of the new field force object. You can just do so much creative stuff with it that has never been possible before in cinema. But I don't like this effect too much right now, so I'm just going to reduce the tracer sample steps again to something like 5 maybe. Oh, disable the sweep. Let the simulation flow. Let it flow, let it flow, let it flow. Oh, that was too much. All right. And now we can enable our sweep again. Let the program calculate for a second, and then we have our nice object. Now this is still not detailed enough, but again, if you're not doing a close-up like this, you are not going to notice. But if you want the detail, just again go to your volume builder, decrease the voxel size, and let it calculate again. All right, let's see what we have. Way better, way smoother. Now keep in mind that this also changes the look of your vectors. The particles are going to move differently because they might come into contact with vectors that haven't been before. So this is all not really something you can control too much. It's more like playing around with settings until you get something that you think looks great. All right, I still think I want more swirls in this, so I'm going back to my let's go to 2, go into the random field, make it visible so I can see what's happening, and make it smaller, something like 450 maybe. Now you can also change the noise type, of course, but something I noticed is that Perlin really seems to work best because others, they just don't yield that great of results. They often clump a lot, but nonetheless you can get really interesting results. Like look at this, blister turbulence just makes a mess out of the mesh. It's not really visually stunning, I think. I don't know, something like Voronoi noise can yield some interesting results, but you have to scale it up most of the time. Something below 500 is not really usable. Just let it calculate. A lot of noises just also seem to trap the particles, so they don't move anymore, as you can see here. They just stop moving, but that's not really a problem, as I said. Yeah, I'm not really a fan of that. Let's just go to standard Perlin noise. Where is it? There we go. Oop. Disable the sweep, as always. And play again. Let it flow, let it flow. And that 200 frames. All right. This is also something you just have to live with. There's a couple of things you can do. Like you can smooth out the vectors by adding a vector smooth, but if you just leave it here now, you can, as you can see, you're just slowing down your particles a lot, which you can also solve by then normalizing the vectors. And then you get really fast vector movement. We have to be careful with that. Go to your field force and reduce it. This was too much. As you can see, it's just something that you just have to play around with. But now we're not getting any more trapped particles because we smoothed out the particles. We don't have like particles that or vectors that force each other into each other, so the particles get stuck. They just move along the surface really smoothly, and there is no particle getting stuck just by adding a vector smooth and a vector normalize to your construction. The particles are not moving fast enough to actually get a good result out of it. All right, and stop. Nice. Now, of course, at any point, because we're working in parametrics still here, you can go back to your platonic and change something or increase the bevel to something more drastic so you get a rounder shape. And it's just going to change what you're doing with your object. 180. All right, and enable your sweep. And bam, you get a nice looking object. Now, if you want to render this, there's like only one way to do it that I know of, and this is unfortunately not an animation, it's just a still, like a static object. If anybody knows a solution to getting the tracer to actually render correctly, please let me know, because right now, even if we cache the MoGraph object and bake it, which basically gives us the particle movement, and we can't cache the tracer, we kind of can't render this. We can render it in the viewport. If we actually enable sweep. We can render it in the viewport, but as soon as we go to the image view or the picture view, we get this result because the tracer is not actually inside the picture view, it's just inside the real-time viewport. But we can make a still, and this is really easy. Just take your sweep, clone it, and current state to object, and delete this, and now we have this ready object. If we hide everything else, just go solo. You can see we have a ready to render object now that we can render in the picture viewer. And yeah, this is basically it. I hope you liked the tutorial. If yes, let me know in the comments. Subscribe, like the video, and of course, as always, if you have any questions, comment down below and ask away. I'm always trying to help. And yeah, enjoy your Cinema 4D session and your new Field Force object. Bye bye!